Hello students, welcome to the class of chemistry, and now we are going to discuss another topic of the chapter, the language of chemistry. So let us get started. We are going to discuss here about the molecular formula, or we can say the chemical formula of a compound. We have studied about the atoms here. Now let me give you the brief description about the formula and the molecules also. See, if I talk about atoms, so atom is usually written as a symbol here. For example, if I am talking about oxygen, so if I am writing here O, which is obviously the symbol of oxygen, so that is equal to one atom, right? And group of atoms, if I talk about group of atoms actually form the molecule. For example, here if I talk about O2, so here what will happen, there are two atoms of oxygen. So this is actually the molecule of oxygen. This is the molecule of oxygen. If I am talking about O3, that means there are three atoms of oxygen. Again, the group of atoms, right? So this is the molecule of oxygen. Okay. Now, if I talk about the molecule, then molecule can be of similar atoms and it can be of different atoms also. So, if I talk about molecule, this can be of similar atoms. Okay, this can be of similar atoms as well as different atoms. Now, what do you mean by similar atoms and different atoms? As I have given you the example of oxygen here, so if there is O2, if there is O3, so this is all the atoms here are of only oxygen. So this is the molecule of similar atoms. For example, H2, Cl2. In H2 both the atoms are hydrogen, in Cl2 both the atoms are chlorine. Okay, but if I talk about different atoms, molecules of different atoms, for example here H2O, okay, CO2. So here you can see that there are total 3 atoms, 2 of hydrogen and 1 of oxygen. So this is a molecule of different atoms. 2 different atoms are there, hydrogen and oxygen. CO2, here also 3 different atoms are there, or you can say 2 different atoms are there, 1 of carbon and 2 of oxygen. So this is the difference between molecule of similar atoms and different atoms. Also, if I am writing this as H2O and CO2, this is called the formula also. This is the formula of water, you know, and this is the formula of carbon dioxide. So in today's session, we are going to discuss that how we got to know that H2O is the formula for water and how we got to know that CO2 is the formula for carbon dioxide. Not only these, we will discuss about other formulas as well. So let us get started with this particular concept. If I talk about a molecular formula, so why it is known as molecular formula again? Because we have seen that H2O is actually a molecule. It is a formula as well as a molecule, so that is the reason why we call it molecular formula. It is also known as chemical formula because it is a chemical compound as well, is a combination of elemental symbols and subscript numbers which is used to show the composition of the compound. Let me tell you again. Let me take the similar example again. H2O and CO2. Okay, H2O and CO2 here. So what they are saying, first of all, this is molecular formula because this is the molecule of H2O, this is the molecule of carbon dioxide. Is a combination of elemental symbols. Elemental symbols means there are 2 elements and there are total 3 atoms. Elemental symbol of hydrogen and elemental symbol of oxygen is being used, and subscript numbers, you can see here 2, this is, we are talking about subscript numbers. Okay, so these are subscript numbers actually. Similarly, in case of carbon dioxide, okay, so all these together they form a formula of a compound. Okay, again we will study this. Molecular formula or chemical formula is a combination of elemental symbols, okay, and the subscript numbers, right? So I think now you have understood this. Okay. Examples, silica. If I am talking about silica, silica is made up of 2 atoms or 2 different elements, not 2 atoms. It will comprise of 3 atoms to be exact, but yes, these are made up of 2 elements, here silicon and oxygen, whereas the number of oxygen atoms are 2. So, total atoms are 3. Okay. Again, calcium carbonate. So, here there are 3 elements, 3 different elements. What are they? Calcium, carbon and oxygen. Here are 3 different elements which combine together in different numbers. The atom of calcium is 1 only, the atom of carbon is 1 only, but the atom of oxygen are 3. Okay. So, here they combine in different numbers to form a particular chemical formula of a compound. Okay. Now, if I talk about another thing here, that is writing the chemical formula. How will you understand, how will you write the particular chemical formula? We will do it step by step. Write the symbol of a basic radical. Here we have, in the previous session we have studied about the positive ions and the negative ions, right? We have studied that Na positive is positive ion and Cl negative is negative ion. So, this positive ion, this is the positive ion, this is the negative ion. Okay. This positive ion is also known as cation and this negative ion is also known as anion. Got my point? Next, this positive ion is also known as basic radical. Okay. This is also known as basic radical and this negative ion will be known as acidic radical. So, this you need to remember. Okay. That positive ion will be known as basic radical and negative ion will be known as acidic radical. Okay. Now, write the symbol of basic radical element with positive valency. Let us again take the example of Na here only. So, here it will be that you need to write it on the first side, that is Na, because it will have the valency of positive valency. To the left hand side, that of the acidic radical. Acidic radical will be written on the left hand side. Okay, acidic radical will be written on the right hand side actually, and positive radical will be written on the left hand side. Okay, to the right hand side. Right. So, this will be on left hand side, this will be on right hand side. Okay. So, first you will write at like this. Okay. Write the valency of each of the respective radicals on right hand top of its symbol. Okay. So, here let us write it again, how you are how they are saying here. NaCl, you can write the valency on top of it or below of it, that is your choice. So, you need to write the valency. You know that in valency we only write number, we do not write positive or negative. Okay, because if we are writing positive or negative, that would be a charge, right? So, Na or Cl, you can write it on the top. If you want, you can write it at the bottom of it also. Next, step 3, divide the valency by their highest common factor. In this case, in case of NaCl, the valency of both is 1, the highest common factor will be 1 and the answer will be 1 only. And if you get the answer as 1, you will ignore 1, because you know we have studied that Na is the symbol, Cl is the symbol and it represents 1 atom. So, we do not have to write 1 again. Okay. Cross the reduced valency. If 1 appears, then ignore it. If a group of atom receives a valency more than 1, then enclose it within a bracket. Okay. If I talk about the formula here of NaCl, because we were studying. So, what will you do finally? Na and Cl, valency is 1, valency is 1. Some people write plus 1 minus 1, but we usually ignore this. So, it is better that you do not write it even. Okay. Next step is to find out the HCF. The HCF will be 1. If you will divide 1 by 1, you will get 1. So, you need to cross multiply this valency. And as I have told you that we do not write 1. You will not write it as Na1 and Cl1. No. You will simply write it as NaCl. Okay. So, this is the formula. Alright. Next. Here we are going to talk For example, this magnesium chloride and ammonium sulfate here. Okay. So, magnesium chloride, you know this, that magnesium, you will write this at magnesium like this, chlorine like this. The valency of magnesium is 2, chlorine is 1. So, here the HCF will be 1. If you will draw out the HCF, if the HCF will be 1 only. So, magnesium and chlorine, you will cross multiply it and you will get magnesium with 1, which I told you that you do not have to write. With chlorine you are getting number 2, so you will add this 2 in the subscript. So, that is MgCl2. This is your formula. This is how you write a formula. If I talk about ammonium sulfate, this is ammonium NH4 positive. So, here you will write what? This is the 1 positive charge, that means its valency. Sulfate SO4, its valency is 2, you will write here. Then again there is 1, so HCF will be 1. Okay. So, here you will cross multiply it. Now, there is one more thing, very interesting thing here, that you are seeing that NH4 is getting 2. So, you will not write this as just like this, or you will not write it as NH42. No, this will be wrong, because here there is a group of atoms, there are multiple atoms here, there is not single atom. Here chlorine was single, but here there is one N, there is 4 H. Okay, so there are group of atoms. So, in that case, what will you do? In that case, what will you do here? Okay, so here in that case, you will put the bracket. Okay, that is NH4. You will put the whole into the bracket, then you will write 2. This is implying that this 2 is being multiplied with nitrogen and with 4 atoms of hydrogen as well, and then you will write SO4. Again, you will not write 1, because SO4 is implying the 1. Okay. So, this is your formula for ammonium sulfate. I hope you have understood this. Next, example of magnesium chloride and ammonium sulfate is there. Now, if I talk about sodium nitrate, let us talk about sodium nitrate. For this thing, you need to remember 2 or 3 things here. Let me tell you this. If you want to write a formula, if you want to derive a formula, you need to know the symbol of element. Okay, you need to know the symbol of element, first thing. And the second thing, you need to know the valency of it. Okay, there are the 2 things that you always and always need to remember about it. So, if you want to see the sodium nitrate, that means sodium, the formula, the symbol is Na. Nitrate, here nitrate will be a compound and this will be NO3. Valency is 1 here as well as 1 here. So, you will simply cross multiply it. We usually ignore the 1. So, the formula will be NaNO3. This is your formula. Got my point? I hope you get it. Let us do one more example. If I talk about another thing, that is calcium hydroxide. Okay, I am saying this is calcium hydroxide. So, there is one calcium and there is another hydroxide. So, you need to remember the symbol for it or the formula for it. So, it will be calcium, it will be hydroxide. The formula is this. For calcium, the valency is 2. For hydroxide, the valency is 1. You will cross multiply it. You will get Ca with 1. So, you will only write Ca, and with OH it is 2. So, now you will not write as it, because now this is group of atoms. So, you will put bracket in it. So, now this is your formula CaOH whole twice. This is the formula for calcium hydroxide. Okay. Next, if I talk about another formula, dihydrogen oxide. Now, what is this dihydrogen oxide? I hope that many of you can answer it. Dihydrogen, there is one hydrogen and there is one oxygen here. Hydrogen and oxygen. Valency of hydrogen 1, valency of oxygen 2. We will cross multiply it. You will get H2O, that is water. Water is the common name and dihydrogen oxide is the chemical name for water. Why di? Because there are 2 hydrogens. So, 2 for dihydrogen, that means hydrogen and oxide. Okay. Now, carbon dioxide. One very good example that how we come to know that it will be CO2. So, see here that how you are going to do this. Carbon and oxygen. Carbon's valency is 4, oxygen's valency is 2. Now, there was one step that you need to find the HCF, that is highest common factor. So, the HCF for 4 and 2 is 2. So, you need to divide it. You will divide this by 2, you will divide this by 2, you will get here 2, you will get here 1. Okay. Now, you will cross multiply it with this. So, you will get as CO2. Okay. So, this is how this formula forms, or you can do one more thing, that if you are not doing like this, so you will write it as 4 and 2, and then you will get the formula as C2O4, and then you are going to divide it with HCF, that is 1 and 2, then your final formula will be CO2. In any case you can do that, but yes, the final formula would be CO2. Okay. So, we have discussed about many formulas here. I hope now you have understood that how you are going to make the formula. Okay. Now, we are going to discuss about the significance of molecular formula, that is what is the importance of the molecular formula here. The molecular formula of a compound has quantitative significance. Okay. It has the quantitative significance, that means in many ways it is showing us some of the quantities. That means it represents the name of the substance, both the molecule and molecular mass of the compound. We can get the molecule of a compound as well as we can also calculate the molecular mass of the compound. The respective numbers of different atoms present in one molecule of compound, we can see that how many atoms are present in the given compound. The ratios of the respective masses of the elements present in the compound, what is the ratio. Now, let us understand it one by one. Okay. The name of the substance, you can easily guess the name of the substance. I have taken few examples. You can easily guess the name, you know this is water. But if I talk about the chemical name, you will say, because there are 2 hydrogens, so you will write dihydrogen, and there is oxygen, so you will write oxide. Okay. Here calcium and CO3 is the formula for carbonate, so it will be calcium. Okay. So, you can write it as calcium carbonate. Okay. NaNO3, there is sodium, and then NO3 is the formula for nitrate. So, that is sodium nitrate. What you will write? You will write sodium nitrate. Okay. CaOH whole twice, calcium and hydroxide. So, you will write calcium hydroxide. So, this is how by the chemical formula you can guess the chemical name of the compound. Okay. Next is the both molecule and molecular mass. What will be one molecule? This will be one molecule of water. H2O will be the one molecule of water. Calcium carbonate, CaCO3 will be one molecule of calcium carbonate. Sodium nitrate, NaNO3 will be one molecule of sodium nitrate. Calcium hydroxide, CaOH whole twice will be the one molecule of calcium hydroxide. So, you will get the idea of one molecule. Now, if I talk about the molecular mass, how you are going to calculate the molecular mass? For calculating the molecular mass, you need to remember the atomic mass. Atomic mass of elements. If you remember the atomic mass of elements, you can easily calculate the molecular mass. For example, the atomic mass of hydrogen is 1 and atomic mass of oxygen is 16. There are 2 atoms of hydrogen, so you will multiply it by 2 into 1 plus 16, that will be 18U. So, this will be the molecular mass. If I calculate the calcium carbonate, okay, so for calcium carbonate, the molecular mass of calcium is Ca, that is 40U, and for carbon it is 12U, and for oxygen it is 16U, as you can see here. Alright. Now, how many atoms are present? Only one atom is present, so you will multiply by 1. Here carbon, one atom is present, you will multiply by 1. here oxygen 3 atoms are present, you will multiply by 3 and then you will get the answer as 40 and 12 and 48, and when you will calculate you will get the answer as 100 U. So what will be the molecular mass of calcium carbonate? It will be 100 unified mass. Okay, let us take one more example here. Sodium nitrate. What is the formula for sodium? Na, nitrate N and oxygen O. Okay, nitrogen for N, oxygen for O. Mass is 23 here, 14 here, 16 here. Only one molecule, only one atom, here also one atom. In oxygen there are 3 atoms. So it will be 23 plus 14 plus 48. Now what will be the final? 8 plus 4, 12 plus 5 plus 3, 15, carry 1, 4 plus 1, 5, 6 and 8. So that is 85 unified mass, if you will see. Okay. The last one is calcium hydroxide. So Ca and OH whole twice. Now there is a twist. For calcium there will be 40, for oxygen here and hydrogen here. Now this 2 is being multiplied with oxygen and hydrogen. That means it will be, for oxygen it will be 16 into 2 since this 2 is being multiplied, and for hydrogen it will be 1 into 2 since this 2 is being multiplied with hydrogen as well. So it will be 40 plus 32 plus 2, that will be 4, and 3 plus 4, that is 7, so 74 unified mass. Okay, so this is how you can even calculate the molecular mass from the given formula. So this is one of the importance of formula. Now if I talk about the respective number of atoms present in one molecule of a compound, so this is actually the atomicity. If I talk about the respective number of atoms present in one molecule of a compound, this is known as atomicity. Atomicity means number of atoms that are present in one molecule of a compound. For example, how many atoms are present here? If I talk about, there are 3 atoms present, 2 of H and 1 of O. So it will be 3. So total number of atoms are 3, and the compound having 3 atoms are actually known as triatomic. This is its atomicity. So we can guess the atomicity also, that this is triatomic. Why? Because this particular formula contains 3 atoms in it. Okay. If I talk about here, there is 1 calcium, 1 carbon and 3 oxygen, 1, 2, 3. So how many atoms? 1, 2, 3, 4, 5. So it will be polyatomic. 5 atoms are there. So it will be polyatomic. Got my point? Next, NaNO3. 1 of sodium, 1 of nitrogen, that is 2, and 3 of oxygen. So it will again be 5. So if it is 5, so we will write polyatomic. Okay. Now CaOH whole twice, 1 of calcium, 2 of oxygen and 2 of hydrogen. Why? Because this 2 is being multiplied with oxygen and hydrogen both, right? So it will be again 2 and 2, 4 and 1, 5. So it will be 5 again, it will be polyatomic. If I talk about atomicity now, so atomicity is actually the number of atoms that are present. So if there is 1 atom present only, for example Na, so it will be monoatomic. Okay. If there are 2 atoms are present, for example O2, so it will be diatomic. If there are 3 atoms present, for example H2O, it will be triatomic. If there are 4 atoms present, for example, what you will give the example of, if there are 4 atoms present, that it would be tetraatomic. For example NH3, so there are total 4 atoms, sorry, it will be NH3, 3 of hydrogen and 1 of nitrogen. Okay, so it will be NH3, so that will be tetraatomic, and after that more than 5, more than 5, it will be counted as polyatomic. Okay, so these are the that you can actually know the number of atoms that are present in that particular formula of the compound. Okay. Now, if I talk about the fourth and the last one, that is ratios of the respective masses present in the compound. You can also get the ratios of the respective masses. For example, you know that we have calculated about the masses. So, you know that water has 18U. That means out of that 2U is hydrogen and 16U is oxygen, isn't it? So, if you will simplify this, you will get it as 1 and 8. So, the ratio by mass of water into hydrogen and oxygen is 1:8. Similarly, calcium carbonate, in 100 grams or 100 U of calcium carbonate, there is 40 grams of calcium, 12 grams of carbon and 48 grams of oxygen, isn't it? Right. So, if you will simplify this, let us simplify this by 2, then it would be, or you can simply simplify this by 4, or yes, let us simplify this by 4 here. So, you will get 10 and then you will get 3 and then you will get it as 12, isn't it? You are going to get it as 12, right. So, the ratio here will be 10:3:12 of calcium is to carbon is to oxygen. So, this is the ratio by mass. Okay. Now, if I talk about sodium nitrate, right, if I am going to talk about sodium nitrate here, so in sodium there is Na, nitrogen and oxygen. Na is 23 grams, nitrogen is 14 grams and oxygen is 48 grams. So, these are the different ratios in which these elements are present in a particular compound by mass. Similar thing happens with calcium hydroxide. Okay. So, I think you have understood the importance, the significance of molecular formula. You have also understood about the chemical formula and how you can make the chemical formula. So, that is all for this particular session. We are going to meet you in the next one. So, take care of yourself.